I come from the Abuja. Yeah, they do class. And they do class, so.
What are your jam? You can just tell you that.
What you tell her? You lie about your jam.
I know it. Hey. I found that game, but I don't do it anymore. No, no, so what's happening? You can't do this. You know what?
Which one we say I don't on audio, boy?
Huh?
I don't on audio. No, I know they make noise, I bet.
That's what he used to last song. Woo! Thanks, bro.
Huh? I don't know. It's supposed to be 2 hours. What time? Guy, anything we off here, I know what's happening. 1, 2. Okay, just to check our audio. Okay. Can you please, if you can hear me, just say you can hear me. Jesus. I don't think I'm still live.
Oh my god, I hate Chinese. Oh my god.
Oh. Bomb, when this kind of thing happen, which I could do? This thing. Okay, very good. For want of time, I think we'll just have to start. I presume you can hear me. For those of you that can, we'll just have to start for want of time, so that we'll not waste anybody's time. Okay. Now, basically, this class we are just going to be touching the biochemistry part of this Bio 151. If we have time, we might not be able to finish everything, but we're going to touch important parts and answer 1 or 2 questions. Before I get into the study, you might be hearing a background noise. Please bear with us. The place I'm in, the generator sound is very loud, and I do not have my mic is not so good. Okay, so just bear with us. I would have to start. With that said, you can hear me. If you can hear me, please just indicate again. Just type I can hear you, so that I can just continue with the class. Please just do that. If you can hear me, just say you can hear me, so I can continue the class. Okay, so I presume you can hear me, and I would like to just move ahead. Now, the aim of the biochemistry part of this Bio 151 is basically to discuss the relationship between the chemical substances in the body and how it relates to our biological processes. Now, it is not your organic chemistry discussed in details. However, it's like an introduction to the concept and some important things you need to know. Now, having said that, to start this part, the first thing I would like to say is that organic compounds are generally compounds of carbon, but there are exceptions to that. That is, there are some compounds that are not necessarily organic compounds, however they possess carbon. So when you talk about organic chemistry, generally organic chemistry deals with the branch of chemistry that deals with the study of carbon related compounds, but the exceptions to those carbon related compounds are CO2 and CO, which are the oxides of carbon, H2CO3, which is the acid, and then any source that has your carbonate ion. So these three things now are not organic. However, when you consider any other compound generally that has to do with carbon, in most cases or most of the time you are dealing with an organic compound. You get, so the emphasis in BCH in biochemistry is just to give us a background knowledge of the different organic compounds in the body and how they generally affect our body. You get. Now, in this study we are going to introduce this concept and classify organic chemistry generally. After our classifications, we will discuss aromatics, we will discuss the alkanes, alkynes, though not in detail, but we'll talk about naming. We are also going to talk about aldehydes and ketones, and possibly, if we have more time, we'll get into the carbohydrates, answer one or two questions, and that will be that. But so far, please, if you are following, just kindly indicate. Okay, so I think I'll just have to just continue, and if you once you don't follow, I'm actually viewing your comments. How the class is going is, if you want to ask a question, you type it. If you are not seeing clearly, you type it. If you can't hear me clearly, you also type it. Before I even continue, I would also appreciate it if you like this particular video. It's going to help every one of us out. Okay, so let's just move ahead. Now, if you enter the class, click on the red, there's this live button. Just click on it. It takes you straight to where we are. The video is going to be online, so you can go back and review, so that you won't just be dragging us back. Okay, now having said that, I think I can now move ahead. Now, as I said, that when you talk about organic chemistry, you are looking at a branch of chemistry that deals with the study of carbon related compounds, and I have mentioned that the carbon related compounds that are not organic are carbon 4 oxide and carbon 2 oxide, carbonic acid, that's triacylcarbonate 4 acid, and you have your carbonate salt. These things are not organic. Every other thing that contains carbon is related to an organic compound. Now, generally, as we know, organic compounds are divided into two. When you say organic, you are looking at two divisions. The first division is hydrocarbon. This is like basic secondary school stuff. And the second division is non-hydrocarbon. So, in describing a hydrocarbon, you are looking at any compound that contains only carbon and hydrogen. The term hydrocarbon simply means that the only thing that is inside is carbon and hydrogen. Non-hydrocarbon means any other thing can be there. So if you have a question and you are given this C2H5OH, C2H2, C2H4, and C2H6, and you are asked to identify the non-hydrocarbon A, B, C, D. Which one of these is a non-hydrocarbon? So let's start with that. Yes, your answers. Which one of these is a non-hydrocarbon? Excuse me. Which one of these is a non-hydrocarbon? So if you have, just put out your answer in the comment section. Amongst everything I wrote, which one of them is a non-hydrocarbon? Okay, yes. So which one is a non? Put out your answers in the comment section so that I would know you are following. Basically, that's why it's a live class and not pre-recorded. Okay, no answers yet. Once I have one answer, I will continue. Which of these? Yes. So Chinkata Uchenna is correct. A is a non-hydrocarbon. Why it is a non-hydrocarbon is simply because, as I said, a hydrocarbon will only contain carbon and hydrogen. A non-hydrocarbon will contain any other thing added to carbon and hydrogen, and the only thing here that contains any other elements is A. B contains carbon and hydrogen only. C contains carbon and hydrogen only. D contains carbon and hydrogen only, which implies that B to D are referred to as hydrocarbons, while A is a non-hydrocarbon. A is an alkanol. We will get to discuss that as we go further. Now, moving ahead, so this is the first broad classification: hydrocarbon and non-hydrocarbon. Now, under hydrocarbons, we have our aliphatics and we have our aromatics. Now, when you talk about the aliphatics and aromatics, first of all, is it majorly has to do with how do I put it? Localization of multiple bonds. When I say localization, I mean that it stays in a particular position. Aliphatics, when they possess multiple bonds, their multiple bonds are localized. But aromatics, if they possess multiple bonds, their multiple bonds are delocalized. What do I mean? If I say a single bond, this is single bond. When I say multiple bond, I mean double bond or triple bond. So in a scenario where I have that inside this compound now, this triple bond stays put. When it stays at a particular location, you say that it is localized. And the particular class of hydrocarbon that is characterized by localized multiple bond is aliphatics. So you can actually put that down: localized multiple bond. Yeah, MB is multiple bond. Here you have delocalized. So that is actually just one major difference between the aliphatics and the aromatics. Now, when you are looking at the aliphatics, if they happen to possess multiple bonds, their multiple bonds stay at a particular point. They don't move. So if, for instance, I have this guy is always here. It doesn't change its position. You get, this is a different scenario from isomerism, which we may or may not talk about. We'll not talk about it in this study because it's not relevant to your this biochemistry. Where you guys are going to do it in your second semester, you get. But for now, have that in mind, that aliphatics have multiple bonds that stay at a place. That is what I mean by localized. But aromatics have multiple bonds that can move from one place to another. That is the difference between the aliphatics and the aromatics. Now, let me just push a little bit further into what I was saying. Now, the major compound that is considered in your aromatic hydrocarbons is benzene. The major compound that is considered is benzene. And if I am to draw benzene, let me explain what I mean. I will talk about structures, but if let me just mention it now. Now, in looking at organic structures, the very important point you need to note is that every junction and every end has a carbon atom. I take it again. Every junction and every end has a carbon atom. See what I mean? If, for instance, this is what we call the skeletal structure. This is what we call the skeletal structure. And I said something that once you have an end and a junction, there is a carbon atom there. So if I want to know the number of carbon atoms in this guy now, what do I simply do? I look at the junction. There's a junction here, 1. There's another junction here. Sorry, this is an end. So 1, 2, 3, and 4. So have that in mind. Every junction and every end has a carbon atom. So let's consider this particular guy now being benzene. I presume most of you should know this structure actually, so I'm not going to overemphasize. So because this is a junction, I have a carbon atom here. This is another junction, I have a carbon atom here. This is another junction, I have a carbon atom here. This is another junction, I have a carbon atom here, here, and here. So the implication is that benzene has 6 carbon atoms. Now, the next thing about benzene is that benzene has 3 double bonds. So I'm just going to put an extra line. You get an extra line and then another extra line. So you notice that the double bond, this is 1 2, this is another 1 2 double bond, this is another 1 2. So how many double bonds do we see here? 3. Just to confirm, I just want to know if we are following. So please, if you are following, just say you are following. So far, if you are following, just say you are following, so I'll know you are still with me. If you are following, just say you are following, so I know you are still with me. Okay. For want of time, I would move ahead and undo na go mess of my wisdom. I presume you've seen the correction and you understand our correction for that particular exercise we had initially. You get, so please take note of that. C2H2 is a hydrocarbon because it contains hydrogen and carbon only. If it contains any other thing, it is now a non-hydrocarbon. Okay, let's just continue. Back to what I was saying. Let me just continue. Yeah. So I was saying something about the aromatics. I said that one thing about this aromatics is this: it has a delocalized multiple bond. So anytime you notice a multiple bond, it means that this multiple bond can move from here and move here, and this one can move here, and this one can move here, which means I can have 2 structures of benzene. One is this one, and the second one is this one. Don't mind my hair. So in this case, this double bond was here, but now it's going to move here. Then this one that was here will now move down. Then this one that was here will now move here. So you notice that this is actually what we refer to as Kekule structure. A big Kekule, whatever. The point is that in his structure, he noticed that aromatics are characterized by constantly moving double bonds, and because of that, he was able to put up a resonance structure for benzene, and you have it to look like this. So anytime you are looking at the structure of benzene, this is what you are looking at as the structure of benzene. So as I said before, once you consider an aromatic, the most important compound in the aromatic is benzene, and the benzene ring is expressed as this. Why? Because this particular bond is delocalized, it is constantly moving. Okay, so I presume at this point we've captured this. I want to move ahead so that we'll now get into these things in details. We'll discuss them in details. Now, let me just take everything out and okay, yeah. So I presume we are following. Okay. Sorry about that. Let me just, I'm trying to. Okay. So as I said, the aliphatics, when they possess multiple bonds, their multiple bonds stay at a place. Their multiple bonds stay at a place. So we have localized multiple bonds. I'm using MB to indicate multiple bonds, while this one is delocalized. When you say something is delocalized, it means that it moves from one point to another. Okay, now let's come to this. Now, under your aliphatics, you now have acyclic and cyclic. Acyclic simply means that it is open-ended and it is straight chain. Cyclic means that there is a joining and it forms a cycle. So when I draw this is, this is actually a cyclic aliphatic. Why is it a cyclic aliphatic? You know, if it was an aromatic, we are going to see the ring here, but because we are not seeing the ring, we know that this is not benzene. This is not benzene though. Why is this not benzene? We are not seeing the ring. Am I communicating? I hope this is clear, because some of you might see this thing and then in your mind you are like, okay, this is benzene. This is not benzene. Benzene ring is either drawn like this. In fact, in most cases it's drawn like this. If you don't see it like this, you will see something like this instead, where you have 3 delocalized multiple bonds. So in this case, you have benzene to look like this or like this. But when you don't have this particular structure and you have it like this is not an aromatic, it is an aliphatic. So the aromatics are characterized by that ring. If you don't see the ring, it is likely an aliphatic. Even if I happen to put a double bond here, this becomes a cycloalkene. We'll get to discuss that, but for now I want you to know that cyclic means that the ends or the carbon atoms will join. So when there is like a cycle of carbon atoms, this is cyclic. Then when it is open-ended, this is acyclic. And if you remember what I said, I told you that if I happen to put out a chain like this, if you look at this structure, each of the end there's a carbon, a junction there's a carbon, see another junction there's a carbon, see another end there's a carbon. So have that in mind. Is this going to be acyclic or cyclic? Obviously this is acyclic. Why? The carbon atoms are not joined to each other to form a cycle. So that is that. I presume I've clarified this. I'm taking my time to discuss this because I wouldn't want confusions when I move ahead with the study. Okay, now having said this, we continue. Now the major aliphatics we have are alkane, alkenes, and alkynes. This is what we should know. Alkanes, alkenes, and then finally alkynes. Under cyclic, all you need to do is just put cyclo in front of it. So this becomes cycloalkane. The second one becomes cycloalkene, and then finally we have cycloalkyne. Okay, I presume we are still following. Sorry, let me just I presume you are still following. Okay. So why is others having a... Sorry, I'm trying to get to understand your question. Why is others having a functional group attached to its benzene group? Like phenol. We'll get to that. Chukwuebuka asked the question. Sorry, let me read the question again. He said, sir, why is others having a functional group attached to its benzene group like phenol? We are going to discuss that, but the point about that particular thing is, you know, you can have hydrocarbons and hydrocarbon derivatives, you get. So phenol is not necessarily a hydrocarbon aromatic directly, it is an aromatic derivative. So just have that in mind. That's to answer Chukwuebuka's question. If you understood what I said, you can actually respond by saying you understood. Okay, so that's that basically. So have that in mind, that phenol, yes, we classify it as an aromatic, but it is not a hydrocarbon, it is a hydrocarbon derivative basically. Okay, so that's that basically. With that, I think I just want to move ahead for want of time because we really have a lot to discuss. Now, with this thing mentioned and what we just said so far, if we consider these two compounds, I will just put out two compounds. If we consider this compound and this compound, okay, so let me just fill in the hydrogen atoms. This is 1, 2, 3, 4, 5, 6 for this guy. And here you have H3, H2, H3. So we'll notice that this particular guy is a cycloalkane. Why did I refer to him as, or to this, it as a cycloalkane? Because it contains only single bonds. So when you think about hydrocarbons that contain only single bonds, you are referring to alkanes. When they have at least one double bond, you are referring to alkenes. When they have at least one triple bond, you are referring to alkynes. I take it again. If they contain only single bonds, they are alkanes. If they contain at least one double bond, they are alkenes. If they contain at least one triple bond, they are alkynes. Now, having said that, I noticed that most of the times when they are describing it in you people's textbooks and your questions in the exam, they use the term saturated. So have this in mind, that whenever you hear saturated, saturated simply means that the compound contains only single bonds between carbon atoms. Saturated, only single bonds. when you hear the term saturated, it means that there are only single bonds. Because you will see questions, for instance, and you are asked, which one of these is a saturated fatty acid? When they say saturated fatty acid, it means that it is a fatty acid that in which between the carbon atoms you only have single bonds. I hope I'm communicating. So when you hear the term saturated, it implies that you only have single bonds. Now, unsaturated, on the other hand, could imply the presence of double or triple bond. So when they say you have an unsaturated fatty acid, a very good example and one of the most prevalent unsaturated fatty acids is your oleic acid or your linoleic acid too. That guy has like 12, double bonds on both 12 and 9 in the case of linoleic, and linoleic it just has a double bond between 9 and 10. And basically that. My point is this: once you see that this particular compound has a double bond or a triple bond, you consider it as unsaturated. Now, for this study in the biochemistry part of 151, we are not going to delve into discussing what makes it saturated and unsaturated. That's where we're going to talk about hybridization. This is a second semester thing, and it is not part of what you need to know now. But just note that when you hear the term saturated, it means only single bond. Unsaturated means the presence of double bond or triple bond. Now, before I continue, I would just like to please ask if you are following. Quietly indicate that you are following. Just say I am following, and then I continue. Just say I am following. That's all I want to hear. Just type I am following. You know this is a live class, so the interaction, for me to know you are still with me, the interaction has to be going. So if you are still following, just say I'm following. So move ahead. Okay, are we following? So I can just move ahead. Okay, so I'll just have to move ahead for want of time, pending your response. Okay, yes, that's okay. Good. So let's continue. Okay. Remember, if you have questions, just put it out. I am monitoring to see if you have questions. Okay, now we've taken that out of the way, the saturated and unsaturated and all whatnot. Okay, so I actually believe that you should have a little bit of basic understanding in organic chemistry. That's why I will not go deep into discussing or defining some concept. As I said, some of these things are things you are going to do in second semester, so if we waste our time, we will not cover much. Now let's go over to the next one. Non-hydrocarbons. Non-hydrocarbons are organic compounds that contain carbon, hydrogen, and any other thing. So if, for instance, I happen to draw something like this, Chukwebuka, I think, mentioned phenol. Yes, phenol is an aromatic non-hydrocarbon. Aromatic because it has the benzene ring. Are you getting what I'm saying? So basically, this is a non-hydrocarbon. Why? It contains oxygen. Hydrocarbon is hydrogen and carbon. So anything that is not hydrogen and carbon in the presence of a compound automatically makes it a non-hydrocarbon, and so on and so forth. So we have that. We are going to discuss other important ones. But for I noticed that in this particular course, what they emphasize as non-hydrocarbons are your aldehydes. So I'm going to just emphasize those ones. Now, your aldehydes are also referred to as alkanals. The next thing they emphasized is your ketones. Your ketones are also referred to as alkanones, and they also emphasize the alkanoic acid, from which we have the fatty acid and the rest of them. There are so many others like the ethers. They made mention of alkanol, so I'm going to talk about that, and extended it into fats and oil are esters. So fats and oil, so have that in mind, that fats and oil are esters. Another name for the esters are alkanoids. You get? Okay, so basically these are the major non-hydrocarbons we are going to like touch or emphasize in this particular class. I presume everybody has this particular table, so I can take it out. Besides, you can actually go back and review the video. It's a public video, so which means you can go back to it and review it if you want, just in case you do not write this thing. So I'm taking everything out and continue. Okay, now with that said, let's like get into real deals now. So in benzene, one of the things that was emphasized, I think, in your course is the fact that the benzene ring, the reason for the benzene ring is as a result of resonance. And when you're looking at resonance, you're looking at how do I put it? You're looking at a particular that is the ability of the movement to occur at the same time. That's actually what I would describe it as with respect in this context. So because the three double bonds move at the same time, they resonate at the same frequency, automatically the movement at the same time is generally referred to as resonance in benzene ring. That is why in that structure it is not regarded as a single structure. Instead, they now put in a circle to indicate that it is constantly moving, and they are moving in resonance to each other, which means they are moving at the same frequency or at the same time. Okay, now it's practically, if you understand resonance in physics, this is actually going to be easier to understand. Okay, now having said this about benzenes, as I said, that is one important thing about benzenes, that they have more or less a resonance occurring, and that is what differentiates it. In fact, one other thing you need to take note of benzene, yes, it's, you know, if you look at benzene, because it has a double bond or a triple bond, it is unsaturated. I mean, benzene has a double bond, sorry, it is unsaturated. So benzene is unsaturated. However, it does not exhibit every property of unsaturated compounds. You get? It is unsaturated, but it does not exhibit every property of unsaturated compounds. So just have that in mind, that the fact that benzene is unsaturated does not mean that it shows every property of the unsaturated compounds. We'll get to understand these things more in second semester. So let's leave this part about benzene and move ahead. Now, the next part of this study I think I need to talk about is, as I said, alkanes. You will notice that they are hydrocarbons with only single bonds. Alkenes are hydrocarbons with at least one double bond. It can be more than one, but there must be one double bond. Alkynes, triple bond. What am I writing? These are things I think we already know, Sha. So let me just, so if you have this single bonds alkane, a double bond alkene, a triple bond alkyne. Now I would like to talk about the aldehyde. Now when you consider the aldehyde is characterized by the presence of what we call carbonyl. And carbonyl is basically a situation where carbon is attached to oxygen by a double bond. So this is the carbonyl group. Now this carbonyl group is found in both aldehydes and ketones. So the two of them, aldehydes and ketones, have the carbonyl group. So how do you differentiate an aldehyde from a ketone? Very simple. I'll just take this out so it will be easier, clearer. Okay, so how do I differentiate an aldehyde from a ketone? Aldehydes possess terminal carbonyl group. So when you see C double bond O terminally, is an aldehyde. But when you look at a ketone possesses non-terminal, non-terminal carbonyl. Okay, I'm going to put down two structures. Structure 1 is C hydrogen, and structure 2 is C. Let me fill the hydrogen atoms. 3 H2 H3 H3. Okay, so between number 1 and number 2, which one do we think is an aldehyde and which one do we think is a ketone? I would like to hear your response. You get? So which one do we think is an aldehyde? Which one do we think is a ketone? Let me just get your response so we can move ahead. It's important I get your response. So yes. First answer. Once I get an answer, I continue. So yes. Which of these is an aldehyde and which of these is a ketone? Which of these is an aldehyde and which of these is a ketone? Which of these is an aldehyde, which is a ketone? Yes, anybody? A is an aldehyde. That is Chinkata Uchenna. Okay, yes, and that's that. Correct. A is an aldehyde. Why is A an aldehyde? Let me just explain that. I'll give more examples, but let me just explain that. Oh, sorry. I noticed I'm not even so live. Okay. Yes. So quickly, let me. So let me explain that. The point about terminal means at the end, and the end carbons are either this one or this one. So when you say terminal, it means the end. Once the last carbon is C-double-bond-O, automatically it is an aldehyde. Terminal C-double-bond-O is aldehyde. Then when the C-double-bond-O occurs non-terminally, you are looking at a ketone. Okay, let me put out a twist based on some of the structures that are in your course, your textbooks. I think, imagine you have something like this. Where you have this, and you have this. Okay. Okay. This is 1, 2, 3, 4, 5, 6. Okay, so this is 1, 2, 3. Okay, so let's look at this, and then let's look at this. Okay, so let's consider the two of them, and then this is number 1 and this is number 2. Which of these two structures is an aldehyde? Which of them is a ketone? Let me use AB instead. Let me use AB instead. Let me use AB instead, so that it will be different from A and B. Which is an aldehyde? Which is a ketone? Because this is very important to differentiate. If you can't differentiate this, we are going to have an issue. You get? So which is an aldehyde? Which is a ketone? A and B. Which of them is an aldehyde? Which of them is a ketone? Once I get an answer, I just continue. But this is going to help us really understand when we get into the carbohydrates. It will help us a lot to understand so much about the carbohydrates. So between A and B, which is an aldehyde, which is a ketone? Look at the structure well. A is a ketone according to Chioma Mary Obu. Okay. Stanley, A is a ketone. B is an aldehyde. Okay, yes. Now, why did we say so? Let's look at the structure. They are all correct. The ones that have put out their answers are currently all correct. Sorry, let me just get back to my board. Okay, so why is this? Where's my pen? So if you look at this guy now remember that there's a carbon atom here. Every junction has a carbon atom, and did you notice that this particular carbon is not the last carbon atom in this continuous chain? You get what I'm saying? Because of that, we are not going to consider this as an aldehyde. It is a ketone. Why? The C double bond O is at a non-terminal carbon. It is not at the end. But in this case now, you notice that this carbon atom is the last carbon here, and because it is the last carbon that is carrying oxygen, automatically this is the aldehyde. And whoa, yes, this is the aldehyde and this is the ketone. Okay, now before I move further, this is one example of a naturally occurring this thing has multiple functional groups. Now you will notice that there is triple bond now in this case, and there is also a carbonyl group, and there is also an aromatic group. So in this case, if you are asked what are the different functional groups, you have your triple bond, you have your carbonyl group, you have the aromatic or the benzene group. You get. So if you are asked an example of a naturally occurring alkyne, this is actually one very good example of a naturally occurring alkyne. The name of this compound, the common name, we will get to the IUPAC name, but the common name is capylene. The common name of this compound is capylene. Major function is antifungal. So when you talk about a naturally occurring alkyne, you are going to consider the capylene as one of them, as one of the important naturally occurring alkynes. So far, are we following? Okay, basically that. Then this other guy is what we call the phenyl carbaldehyde. We are going to come back to naming these things though, but I just want you guys to notice the difference between these two. We'll get to the IUPAC nomenclature of this guy, but I just want us to be able to identify the functional groups. Now when you see an alkanone, you know this is an alkanone. When you see a ketone, you know this is a ketone. Okay, finally, before I get into the other parts, imagine I have a structure of a monosaccharide sugar. I'm going to put out a structure of two monosaccharide sugars. You get so here H2OH, OH, OH, H, double bond O, H, OH, OH, H, and then we have another one. 1, 2, 3, 4, 5, 6. Here we have double bond O, H, OH, 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 H. Okay, so let's consider these guys. This is glucose and this is fructose. You get the difference is basically based on one of them is an alkanone and one of them is an alkanal. So this is X and this is Y. So let's identify, is glucose an aldehyde or a ketone? Is fructose an aldehyde or a ketone? So identify quickly, do that quickly. So you just write, how to answer is just write X is an aldehyde, or glucose is an aldehyde, fructose is a ketone, or glucose is a ketone, fructose is an aldehyde. Okay, so do that quickly. So what do we think? What do we think? What do we think? So what do we think? Is glucose an aldehyde or a ketone? Is fructose an aldehyde or a ketone? Okay, Choma says glucose is an aldehyde. Okay, which means fructose is a ketone. Okay, that's Choma's answer. Yes, any more? Just one more person and I move ahead, so that our ability to understand this thing will help us be able to answer questions better. So please do this quickly so we can move ahead. Okay, good. So Chuku Ebuka Stanley says X aldehyde and Y ketone. Good. Now, if you noticed, how did we get to that conclusion? It's quite simple. I told you that what you used to know aldehyde is that the carbonyl group C double bond O will occur at the terminal carbon. But once it is occurring at a non-terminal carbon, this is a ketone. So this is what? A keto monosaccharides, and this is what we refer to as a ketose, while this is what we refer to as an aldose. So which means glucose is an aldose and fructose is a ketose. Have that in mind. Before I leave, okay, we'll discuss that in carbohydrates. Let's just move ahead now. I've mentioned this. The other thing I would like to mention is alkanol. Alkanol, how do you know alkanols? Once you see OH, hydroxyl group. Once you see OH, that's a hydroxyl group. You will know that that is an alkanol. Let's say, for instance, now if I consider this particular compound and I put OH here, automatically this is an alkanol. How do I know? Because I see OH, basically. You get. Now the only thing is that there are now classes of alkanols, and I think it's important to take just a brief note of that. For us to understand the classes of alkanols, I would like us to look at this and understand the classes of carbon quickly. I'm going to run through this as fast as possible so that I can see if I can get to carbohydrates today. 1, 2, 3, 4, 5, 6, 7, 8. Now, all these numbered carbon atoms are classified into 4: primary, secondary, tertiary, and quaternary. I said primary, secondary, tertiary, and quaternary. Well, that's not quarter. You get. So these 4 classes, these are the 4 classes of carbon atoms, and these 4 classes will help us understand the classes of alkanols. So please, let's take note of that. Now, what is a primary primary carbon? A primary carbon is the one that occurs at the end, and if we are looking at them, number 1 is primary because it occurs at the end. Number 8 is primary. This is the last in this side now. Like there's no other carbon after it. 5 is also primary. There is no carbon after it. 6 is primary. There is no carbon after it. 7 is also primary. So the concept of primary is terminal carbon atoms. Now, the other thing that is used to describe a primary carbon is that a primary carbon is a carbon atom that is directly attached to only one. It is directly attached to only one carbon atom in the chain. So this guy now, carbon, is attached only to one carbon. So this number 1 is primary. Number 6 is attached only to number 2. So this number 6 is primary. Number 7 is attached only to number 3. So you notice that it is only attached to one. Every primary carbon atom is attached to only one carbon atom. So you have that in mind, that a primary carbon atom is attached to only one carbon atom. I hope this is clear. If you followed, please indicate. If you followed, please indicate. Okay, so that's that basically. I think I can move ahead. But yeah, you all are correct so far. The ones that have put out their answers so far, you are correct. Okay, Chamaka Asokwa, I followed. Okay, so let's continue now. Yeah, moving ahead. Yeah. Okay, so if primary, now see the point. Primary is attached to one. That means secondary is attached to 2 carbons only. Tertiary will be attached to 3 carbons, and quaternary will be attached to 4. So let's check which one of them will now be secondary. Oh yeah, let's put out our answers. Which one is secondary? Is it C2? Is it C3? Is it C4? Is it C5? We are looking for secondary, and we said secondary is attached to only 2 carbon atoms. So let's put that out quickly. Which one is secondary? Which carbon atom is secondary? Which carbon atom is secondary? Which carbon atom is secondary? Which of these carbon atoms is secondary? Okay, so let's do that quickly. Oh, you know, I forgot a particular part of this equal study. The inorganic BCH part. Okay. No worries. We'll see what we'll do. Even if it means we'll show you. Okay, so yes, C4 obviously. Why is it C4 obviously? It's very obvious because Kenechukwu Apado, let's come back to the board. So everybody look up. If you consider number 4, it is only attached to number 3 here and number 5 here, which means this guy now is attached to only 2. If you look at number 2 now, number 2 is attached to number 1, number 2 is attached to number 6, and number 2 is attached to number 3. So it's attached to 3, which means number 2 is tertiary, and that means that number 3 will be quaternary. So yes, the secondary here is the one that is attached to only 2, and that is C4. Now I think the rest can be determined. Why I brought this up, this is not majorly in the BCH we are doing now. Ebunge, where you're going to do this thing majorly is in your second semester, but I brought this up because there was a question that had to do with conversion of ethanol to ethanol, and you need to understand something about that. Now, if you want to know a primary alkanol, alkanols are classified, monohydric alkanols are classified into 3: primary, secondary, and tertiary. A primary alkanol, you have OH attached to a primary carbon. So if I draw a chain of carbon atoms and put the OH here, you will find out that this is primary. Why is this a primary alkanol? It is an alkanol, first of all, because it has OH, and then it is a primary alkanol because the OH is attached to a primary carbon. Okay, if I draw this other one I drew now, what type of alkanol is this? Yes, comments. Let's comment, because this is a class, so I actually want to have your response to 234. Omuchioma Mary, the 234 I don't understand it. And Kenneth, I presume I've re-explained, so you should understand it by now. Okay, yes, so yes, 234. No, it's not 234. It's not 234 because number 4 is the only one that is attached to only 2 directly. You get, so please review your answers. Number 2 is tertiary because it's attached to number 1, number 6, and number 3. Okay, Chukwuebuka Stanley said it's secondary. Obviously, yes, it's secondary. Very good. Nice. So let's move ahead. Okay, good. So this is secondary. Why is it secondary? Because OH is attached to secondary. Very good. So this one is secondary. We will still do all this in secondary alkanol. We will still do all these things or discuss this in detail by second semester. But you know, I'm just trying to highlight the ones that are related to the questions I have seen in your exams. Now let's move ahead. Now with that said, why did I bring this up? Why I brought this up is because one of the major reactions that you are going to take note of is that an alkanol is converted to by oxidation to an alkanal. But the type of alkanol that is converted to an alkanal first is what we call primary alkanol. I take it again. A primary alkanol is converted to an alkanal first when it is oxidized, and after that alkanal is formed, that alkanal is further oxidized to an alkanoic acid. So just have that in mind. So I presume we are following. If we are following, let's simply comment that we are following. Okay, I presume. Oh, sorry. I'm trying to ensure that my connection. I hope there is no break in transmission so far. I was just trying to confirm if we are still here. Okay, very good. Now, as I was saying, good. Let me continue. Now, as I was saying, I said that a primary alkanol is oxidized to form an alkanal, and then that alkanal is now further oxidized to form alkanoic acid. Before I continue, I just want to emphasize something, that first of all, this oxidation here is partial. So partial oxidation of primary alkanol will give alkanal, but complete oxidation of alkanol, primary alkanol, will give alkanoic acid. Now see what I mean. If for instance I have ethanol, ethanol is a primary alkanol. If I oxidize it partially, what I am going to get is ethanol. Please remember that alkanal is the same thing as aldehyde. So just in case you are wondering where did alkanal come from, is the same thing as aldehyde. So which means ethanol will give ethanol, and when I further oxidize it, it is going to give ethanoic acid. This is no big deal, it's et. But the point is, nol gives nal, which gives noic. I presume we are following. So you get that. Okay. Imagine I say propanol, or everybody, propanol. Can you tell me, after oxidation of propanol, what am I going to get? So put the answers out, so we'll continue. That's the first step. What will it give me first, and what will it give me finally? So I will move ahead. Okay. Okay, no, I said propanol. Aaron Smith, I think you should actually consider the reaction again. You know, I said an alkanol, primary alkanol, will give a corresponding alkanal, and then it will now give a corresponding alkanoic acid. So when propanol, yes, but Obuchioma, what is the name of the alkanal it will give, the aldehyde it will give? That's what I want to know. So Chinkata Uchena, you are correct. It should first give a propanol and then give a propanoic acid. You get the point now. So let me just continue with that, because for want of time, to see if I can at least achieve something before my time. Okay, now, so we said propanol will first give propanol, and if you further oxidize it, you are going to have propanoic acid. So that is the chemistry of it. And before I even continue, you know, when you say oxidation, you know, in our jam time, we are told that there are 6 definitions of oxidation. You get, and the major definitions have to do with oxygen, hydrogen, electropositive substance, electronegative substance, electron transfer, and oxidation number. For chemistry, we major on electron transfer and oxidation number. You get, and that's where I actually worked out an acronym: OILE, RIGE, O-ion, radon. What this acronym simply means is oxidation is loss of electron, reduction is gain of electron. Oxidation is increase in oxidation number, reduction is decrease in oxidation number. Now, but for this thing now, we don't need loss of electron, and we do not need oxidation number. What we are going to be considering is oxidation with respect to addition of hydrogen or removal of hydrogen, or oxidation with respect to addition of oxygen or removal of oxygen. So please listen. Oxidation means add oxygen or remove hydrogen. Reduction will now mean remove oxygen or add hydrogen. Now, why did I bring this up? Because I want to talk about the enzyme that is responsible for this particular conversion in the liver. Now, you will notice that most of you will have noticed that when, for those that take alcohol, if you finish taking alcohol, for instance, you have your headaches and the other things associated with your hangovers. After the alcohol don't do what you do, you sleep, wake up, you now see that you have like this migraine headache and stuff. You get, caused by the hangover effect. Let's call them the hangover effect. So the question is, this hangover effect, what actually causes the hangover effect? Now, the alcohol we take in that is okay for us to take is ethanol. And ethanol, no, not that. That's not. Ethanol, when we oxidize ethanol, it is going to first give us ethanol. Now, this is an oxidation process, and it involves addition of oxygen or removal of hydrogen. If you are asked what enzyme is responsible for converting ethanol to ethanol, you get, because I said this ethanol is responsible for hangover effects. Is responsible for hangover effect. So when you are considering the whole effects of hangover, see what they call some ethanol. The other name for ethanol is acetaldehyde. We'll get to that. We've not gotten to naming acetaldehyde. But for now, just know that ethanol is oxidized to give ethanol, and this is what causes hangover. Now, what is the particular enzyme that causes this particular ethanol to be produced in the liver? The enzyme is what we refer to as alcohol dehydrogenase. Alcohol dehydrogenase. Now, why did I want to describe this thing this way? Oxidation is dehydrogenation. That's removal of hydrogen. So it tends to help you keep it in your head that when you say remove, dehydrogenate an alcohol, the ACE or the enzyme that is responsible for removing hydrogen from an alcohol is alcohol dehydrogenase. And you notice that is oxidation, because oxidation is the removal of oxygen. What am I saying? Oxidation is the removal of hydrogen, sorry. So please have that in mind. This is alcohol dehydrogenase, the enzyme responsible for removal or the oxidation of ethanol to ethanol is alcohol dehydrogenase. Okay, now if for instance, I hope we are following. Sorry, let me just get our response. I hope we are following. Remember, we said that oxidation is removal of hydrogen, that's dehydrogenation. So the enzyme involved in dehydrogenation that's dehydrogenation to form ethanol is alcohol. Instead of dehydrogenation, you just put nase indicating the enzyme. You know, we have them sucrose hydration is caused by sucrase. We'll get to that when we get to carbohydrates, but I just want you to take note of that when you are considering the enzyme that converts ethanol to ethanol, you are looking at your alcohol dehydrogenase. Why? This conversion is oxidation, which is the removal of hydrogen, and dehydrogenation is the removal of hydrogen. So I'm just putting out things that might help you remember this particular enzyme. So I say it is referred to as the alcohol dehydrogenase. Sorry, is this understood? Okay, good. Now please write the second part again. Mesoma wisdom, I think you would have to like clarify. Okay, I think you are following now. Okay, now let's continue. Now the question I would like to ask now is, if alcohol dehydrogenase gives ethanol, what do we think? You know, this is still a dehydrogenation process to give ethanoic acid. Okay, so sorry, let me just remove this thing. So what do we think is now the enzyme that converts ethanol to ethanoic acid? Remember, what is happening here is dehydrogenation, removal of hydrogen. So what dehydrogenase will give ethanoic acid? I want us to think with me. If alcohol dehydrogenase gives ethanol, what dehydrogenase will now give ethanoic acid? Because once you are dealing with oxidation, you are dealing with a dehydrogenase. Just have that in mind, that anytime you are dealing with oxidation, anywhere oxidation is occurring, the enzyme associated with oxidation is the dehydrogenase. So yes, what do we think? So what do we think? Before I continue, what do we think? Yeah, so what do we think? Alkanal dehydrogenase. Okay, yeah, that's a smart one from Chiamaka. Yeah. Okay. Ethanol dehydrogenase. Okay. Yes, you guys are getting the point now. But basically, I would preferably say alkanal dehydrogenase because any alkanal at all. It acts on any alkanal, not necessarily ethanol alone. It's acting on any alkanal. So, but specifically, I think what it's being referred to as in most biochemistry textbooks is not alkanal. There are jargons that are used or terminologies that are preferably used. Most times they don't refer to it as alkanals, they refer to them as aldehydes. So please, the enzyme in this case would now be aldehyde dehydrogenase. Aldehyde, it won't enter here, so let me just write it here. Aldehyde dehydrogenase. Okay, so I hope this is clear so far. Yeah, with that said, I think let me just see if I can find a question related to this. Let me just check to see my catalog. Where's my OBS? Sorry, I'm coming. No. Sorry guys, I'm just trying to see if I can find a related question to this so that we can answer. Okay, I think I've seen one. Yeah. Okay, so I presume everybody can see this. Let's just answer question 87. What do we think is the answer to question 87? 87. What's the answer to question 87? Yes. Is it already in the screen? Yeah, question 87. What do we think is the answer? The enzyme that catalyzes the conversion of ethanol to ethanol in the liver. Ethanol to ethanol in the liver. What do we think? Yes, let's put out our answer. Question 87 specifically. Question 87. Okay, A, that's the answer. You get Shamaka Asokwa, you are correct. Why? Because you are converting null to null, and that is a dehydrogenation process. Very good. Okay, now let me just put out a twist to this thing, just to see if we are actually following. I will come back to the other questions later. You get, but let's. Okay, now I want to just take everything out and okay. So if we say that an alkanol, the forward process is oxidation, is oxidized to give, primary alkanol is oxidized to give alkanal, and then further oxidized to give alkanoic acid. And we said that the enzyme for this process is aldehyde dehydrogenase. the term dehydrogenation is the same thing as oxidation. Then this one is alcohol dehydrogenase, meaning oxidation. Now, if we are dealing with a backward process would now be hydrogenation. I hope we know that. If we are dealing with the backward process, the backward will now be reduction. This is going to be reduction. Now, because we are going to be doing a reduction, I hope we know that the enzyme involved will now be a reductase. So in this case, this is going to be an acid reductase or alkanoic acid reductase. Then what do you think is the enzyme involved in converting alkanal to alkanol? What do we think is the enzyme responsible for converting alkanal to alkanol in when we are doing the backward process? What do we think? Alkanal to alkanol. Okay, so I said if it is alkanoic acid to alkanal, you are looking at an alkanoic reductase. I told you reducing enzymes are referred to as reductases. Like, it's actually quite simple. If you understand the process, the enzyme would actually be easy to understand. So I said this is an acid reductase. So what would the other one be? This is an acid reductase to give an alkanal, which means if I want the alkanal to now give alkanol, primary alkanol, what will I now call it? Yes, what do we think? What do we think is going to be the name of this one? An aldehyde reductase, correct? You get, because the aldehyde is being reduced. That is, if Ebuchigen Francis, your answer is correct. So I think I can move ahead. This is not necessarily Choma is not reducing the alkanol. The alkanal is being reduced to alkanol. So the particular compound that is reduced is alkanal, not alkanol. Are you getting the point? So you say alkanal or aldehyde reductase because you are reducing alkanal. You are not reducing alkanol. I hope this is clear. Choma Mary, indicate if you understood what I just explained. Can you please just put up your hand or wave or something for me to know? Okay, yes, aldehyde reductase, correct, and so on and so forth. Okay. I think should just move ahead for want of time. Let's just move ahead. Okay, so I see we are following to a very great extent. Now, okay, I didn't mention the secondary alkanol. Now, a secondary alkanol, on the other hand, a secondary alkanol would give an alkanone or ketone, and ketones can not necessarily be oxidized further. You get what I'm saying? By normal oxidizing agents. You get, so if you further oxidize a ketone, you have no reaction. You get, but when you oxidize a secondary alkanol, you get an alkanone or ketone. Okay, so which means if I happen to oxidize propan 2-ol, we are going to do a proper study on, we'll touch naming after this actually, so that if we have propan 2-ol, propan 2-ol will be oxidized to give what? It will give an alkanone. And what is the alkanone going to be? Propan 2-ol. Very simple. So please have that in mind, that when a secondary alkanol is oxidized, it just gives the corresponding alkanol. Is this clear? Okay. Cynthia Ezine, I think she just what question are you answering? I'm not so sure what question you're answering, Cynthia. You get, however, if I'm clear on this, your answer, you are dealing with the backward, so it's reductase. I don't know. probably review the video again to understand it. Okay, I presume this is clear, so I'll have to move on. Okay, let me just ask one question just to be sure that you understood. So I said if propan-2-ol gives propan-2-O non-oxidation, what if I now have something like butan-2-ol? If it is oxidized, what will it now give me? Oh yeah, everybody, what do you think is going to give me? Butan-2-ol. If butan-2-ol is oxidized, what will it give me? Okay, so put it out. If butan-2-ol is oxidized, what is it likely to give me? Butan-2-ol, if it is oxidized, what is it likely to give me? Butan-2-ol, if it is oxidized. Okay, let's bring our answers. There's a little bit difference in the timing of where I am and where you guys are. Yes, any answer, just one answer and I just continue. One answer, I move ahead. Correct, butan-2-O. Very correct. Nice. Makes sense. Okay, let's move ahead though for want of time. Now the next part I think I need to touch before, today's class might have to reschedule, because currently it's almost 2 hours already. You get, but let's just continue. Now I would love to talk about naming. The reason I would like to talk about naming is I'm seeing a lot of names here or structures, you get. But before I talk about, yes, let's just get into it. Before I talk about the rules for naming, I would like to give you what we call order of priority. Order of priority is like an arrangement of the major functional groups in the basis of which one is the most important or which should be considered first. You get. Now in the order of priority, order of priority. Oh my god, I hope people can see my handwriting. Don't mind it. Priority. Now in the order of priority, the first guy we have in that particular chain or table in the order of priority is the alkanoic acid. Now what does this simply mean? I will try to explain as much as I can. It simply means that if you have a particular organic compound, alkanoic acid is represented by the presence of COOH. I take it again. Alkanoic acid is represented by the presence of COOH. You get. Alkanoic acid is represented by the presence of COOH, which means that once you are dealing with, once you see this thing, just know say na alkanoic acid. You get. Okay, if I write CH3COOH, this is also an alkanoic acid. Okay, but that's not why I brought this up, because I'm trying to give you a general concept behind it. Now if I have this and I have let's say I have OH here, you get. Now you are noticing two things. OH is for alkanol, COOH is for alkanoic acid. So the question is this compound an alkanol or is it an alkanoic acid? On the basis of order of priority, alkanoic acid is above everybody, which means once you see COOH in a compound, automatically that compound is an alkanoic acid. Every other thing that you see there will now become a substituent. That is, it will not be the main chain. So if I'm to name this compound now, this compound is going to be 4-hydroxy butanoic acid. Okay, sorry, that's not, there's not supposed to be space. 4-hydroxy butanoic acid. I will come to the naming part too, but I want you to understand this thing, because what I'm going to give you is just a general concept of naming. We're not going to get into it in so much details, because where you guys are going to do this thing is in your chem, I don't know the course code, but I know it's in second semester that you're going to do it. So just have this in mind. That's based on order of priority. Alkanoic acid is the boss above everybody. So once you see COOH, just know that that compound is an acid. You get every other thing has to fall as a substituent. Okay, imagine you see something like this now. You see something like this. You see the benzene ring, and you now see COOH, and they ask you what is the name of this compound. This is phenyl methanoic acid, or you call this benzoic acid. You get, which means because of the presence of alkanoic acid, it becomes the most important factor there. Please, if you are following, just say you are following. If you are confused, indicate your confusion so that I will re-explain. Okay, I'm waiting for a response actually, so that I can move ahead. Because if you don't understand this order of priority here, it will hard you to name. You get. I will describe the order of priority. Yes, if you are following, just say I'm following. I just want one I'm following so I can move ahead. Okay, good. So with that said, it means that once you have alkanoic acid, that's COOH in the compound, that is the first, that's the compound will be an alkanoic acid. You get, so that's that. Very good. Okay, now let's continue. Now, having said that, let me just remove this guy. Let me just remove it quickly so we can move ahead. Sorry about that. Okay, now having said this, the alkanoic acid, as I said, the functional group is carboxylic. When I say carboxylic, I mean COOH. So when you see COOH, if you don't see it like this, you see it like this, COOH. Once you see this thing, just know that alkanoic acid is that thing. You get, and this is what we refer to as carboxylic. It is the most important functional group in any organic compound. Now, if you don't see an alkanoic acid, you might, the second thing you consider is your esters or any derivative of alkanoic acid. There is ester, there is alkanoil. Those ones we are not discussing this in this video, but why I want to talk about esters is because fats and oils are esters. So have that in mind. Fats and oils are esters. They are majorly referred to as triglycerides. We will discuss that under lipids. But just have that in mind that fats and oils are esters. They are esters that are formed by esterification reaction between alkanoic acid, that is fatty acid, and glycerol. But let's leave that, we'll get to that. Now, esters are the second group, and esters, the functional group of esters is the carboxylate. Carboxylate is C double bond OO without hydrogen. Just I'll discuss this some other time, but you just see COO. Once CCO and there's no hydrogen ending it, is an ester. But if it is hydrogen ending it, is an alkanoic acid. Now, moving down, you have your amide. The amide is the next guy, and amide is represented by C. Yes. So the amide is when a carbonyl group combines with amine. So this is the amide group. You get what I'm saying? We are going to discuss this in details in organic chemistry in the second semester. But just note that the amide, what we need to know in this particular study is the amines, because that's where your amino acids then come from. We'll discuss that hopefully later on. But just note that the second guy you notice after ester is amide. Now, after amide, you consider your aldehydes. Your aldehydes, that's alkanal. Before we consider the ketones. The ketones are also referred to as alkanones. Okay, and after those guys, we can now get into alcohol. Before we consider alcohol is alkanol. Before we consider amines, then we can consider your aromatics. Then we can consider alkene, haloalkane, and the rest of them. These other ones I'm writing are not like very important, you get, but these ones I don't write now are the ones we need to know for this particular study, you get. Okay, now let me just explain what I mean. Woo. Okay. Okay, I think we might have to reschedule. The simple reason is my generator don't off. You get, but let me just keep going because the laptop will soon go off, you get. So we might have to reschedule. And what time do you think we need to reschedule? Because my gen is already off and there's no light. So what do we think? We might have to reschedule. I will say one thing about this and then I will keep talking till it's off, but I'm just saying it because it might go off anytime, you get. So what time do you think we should reschedule? Put out your comments, but let me just continue the class. That's another day, not today, dependent on your exam. Anyway, now back to what I was saying. I said let me just describe what this actually means. See what this means. Imagine I have this particular chain. Now I have this chain and I have NH2. This compound, is it an amine or a carboxylic group? Because carboxylic group, alkanoic, is higher than amine, automatically this compound will end as an oic acid, you get. So if I'm to name it and I'm to consider anything first, I should consider this thing. Now why I had to mention this order is you also need to consider this particular order when you are allocating locants. Locants are serial number to carbon atoms. If I want to give serial numbers, that's number 1, number 2, number 3 and number 4, which one is number 1 here, I will check for the carbon atom that is closest to the functional group of highest priority. The functional group of highest priority here is carboxylic, that is COOH, which means if I want to number it, I'm going to start from here. 1, 2, 3, 4. Why? Because this is the functional group of highest priority. I hope I communicated. Okay, let's say for instance I'm dealing with something like CH3. No. Let me change that. Let's say we have CCCCH. Okay, so let's consider this compound. The two functional groups that we can see here are the alkyl, that's carbonyl, this alkyl or aldehyde, and amine. So please, am I going to start numbering from here or from the other side? So please, where is the numbering going to come from? Is it going to come from the right side, which is arrow, or from the left side? So answer, so we can move ahead. Are we numbering from the right side or the left side? So are we numbering from the right side or from the left side? Yes. From the left side. Kenetsuku, did you consider the order? Now if you look at the order, you will notice that this what's the column, aldehyde is higher in priority than amine. I presume we all have. Yeah, Asokwa, you are correct. Why are you correct? Because aldehyde has a higher priority. I would rewrite. Let me rewrite that order again so that we'll see it. I'm writing the order on this side. So the order is, first of all, okapatapata is alkanoic acid. After alkanoic acid, you have your ester. After ester, you have amide. Amide is not amino. Amide is C double bond O that is directly attached to NH2. So this one is not amide, this is amine. When NH2 is attached to carbon, you refer to it as amine. But when NH2 is attached to C double bond O, it is now amide. I'm just trying to differentiate it. You get? So amide, I think that's where our confusion comes from. So amide, before you have your aldehyde, then you have your ketone, then we have our alkanol and amine. If you look at amine is carbon attached to NH2, but amide is carbonyl attached to NH2. So with that said, I presume our confusion is clear, is it? Okay, you get the point now. Good. So that's that. Basically, they are not the same thing. Okay, so which means if we are to number this thing, if we are to number this thing, where is it? Let me number it. Yeah. So where's my board? If we are to number this thing, our numbering will now be 1, 2, 3, 4. Now, if you want to name this compound, it's quite simple. 4 carbon atoms indicates boot. The Latin name for 4 carbon atoms is boot, which means once you see 4. Okay, I think it's back. Okay, so as I was saying, that once you have 4 carbon atoms, you are considering boot. You get now, but the question is, what is this boot? This is an alkanal, so this is going to be butanal. Remember, it's not going to be butanamine because the higher priority is aldehyde over amine, which means this amine will now become a substituent. So that's the first thing I want you to take note of, that the parent chain here will now be butanal. Now what do we do with this amine? This amine will now come as a prefix, that is a substituent, and the name of this compound will now become 4-amine butanal. Now I have not gotten into the details of naming. I'm just trying to help you understand this thing we refer to as order of priority. Now my laptop is going to go off soon, so what I'm going to do is I'm going to let me quickly copy the link for the study on naming and put it out here. Then I will now talk about how we schedule the class. You get, I will discuss with anybody, the places you saw the link, just contact those people. They will tell you on how the rescheduling of classes will go. You get, because my laptop is about to go off. So what I'm going to do is I'm going to share a link to naming. Just is a for how many minutes? 15 minutes study. Just go through it and you understand the general concept behind naming. When we come for the rescheduling, it makes it easier for me to describe it. Okay, so I'm just going to quickly copy it. Let me quickly copy the link. Before my system goes up, and put it out here so that okay. The link, where is it? Okay, so yeah, let me just okay. Okay, this is the first link. This is the first one you should use. Let me put out the second one. Let me do that quickly so we can round off here. This is the first one. This is the second one. Like, go through these studies before our rescheduled class, so it makes it easier for us to understand. This is just generally naming concepts. Now this is for alkanes. However, anybody that understands the meaning of alkanes, it becomes easier to understand the rest of them, because that is what we're going to do in our next rescheduled class. We'll talk about the rest of them, get into carbohydrate properties, talk about lipids, and talk about buffer solution, and somehow round it up. So which means you guys should go and be doing up the reading of all these important macro and micro elements. Please go and read those things up yourself. And then before I even leave this, I beg, Mona like my study now. I not really like what they learn. But I like the video now. Not only 16 likes I don't see, and they should say and I plenty we don't come inside. You get. Don't forget to subscribe to this channel though. You get, you gain a lot of things. Now I'm going to put out 2 more links. Just look up all those studies, so that by our rescheduled class it becomes easy for me to, and faster, we'll cover more things in less time. You get. Where is types of organic structure? Shareable link. Okay. So follow this particular thing in the order I put it out. That is the first link I shared. You look up that one first. The second one you look it up. Then the third one look it up, and then the final one. This is the final organic names structure. Yeah, so take it in this order. If you really want to understand the study, take it in that order. Okay, so just take it in this particular order. We're going to be stopping here for today. My laptop is about off and my generator not off. Okay, thank you guys for having me. See you guys in the next class. Thank you. So we've rescheduled. I am not sure of what time, but since we said tomorrow, I'm going to put out I will discuss with whoever you saw the link on his page or status, and we would work out a reschedule. Thank you very much for your time.